So section 3.3, the product and quotient rules. So let's check that. The first thing, if we have two functions, f of x equal x squared and g of x equal x cubed. The product rule, that means if I multiply these two functions, f of x times g of x is going to be this side. Now they ask you, is this side equal to that means if I find the product of these two functions and then find the derivative, is going to be the same thing if I find the derivative for the first function times the derivative for the second one. It's going to be the same result from both sides. Let's check that. For the left side, the derivative of x squared times x cubed. When I multiply exactly the same base, I can add the exponents. That means on this side is going to be, it's the derivative of x 2 plus 3 is going to be 5. I'm talking about only the left side, because this is one of the exponent rule. If you multiply the same base, you're going to add the exponents. The rule says if you have a, which is a base to the exponent n, times a to the exponent m, you can say a n plus m. This is one of the exponent rule. That's what I did here. Then the derivative for x to the power 5, I'm just going to write down 5, and here is the x. 5 minus 1 is going to be 4. So this is for this side. Now let's check the other side. If I find the derivative for the first function, the derivative for x squared is going to be 2. And here is the x. 2 minus 1 is going to be 1. Times. If I find the derivative for the second function, is going to be 3. And here is the x. 3 minus 1 is going to be 2. Now, if I multiply these two sides, these two functions, 2x times 3x squared is going to be 6. X 1 plus 2, 3. Check, we have two sides, but these two sides are not equal. That means there is a rule. You're going to check the rule. The product rule. To find the derivative of a product between two functions, the rule says the derivative of f of x times g of x is going to be the first function times the derivative for the second one. That means you're going to write down the first function times you're going to find the derivative for the second one, plus the second function times the derivative for the first one. So you have to memorize this rule. You're not going to keep looking to the rule when you're solving the examples. It's two functions. When I find the product between these two functions, the derivative of a product is going to be the first one times the derivative for the second one, plus the second one times the derivative for the first one. So now we're going to go back to this side. We're going to go back to this side, and we're going to try to find the derivative for the product for these two functions. That means there's going to be the first one, which is x squared, times the derivative for the second one, which is d over dx, for the second one, which is x cubed, plus the second one, which is x cubed, times the derivative for the first one. We're just doing exactly the same rule, but we don't have to do these steps. When you solve the examples, you're going to go right to the next one. So here is x squared. The derivative for x cubed is going to be, here's the exponents, x, exponents minus 1, 3 minus 1 is going to be 2. Plus, here is x cubed. The derivative for x squared is going to be times exponents, and here is the x. 2 minus 1 is going to be 1. Next step. I'm going to multiply these two. 3 times 1 is going to be 3. And here is x. Multiplying the same base, you're going to add the exponents. 4. Because you're multiplying. When you multiply, so you're going to add the exponent because they are the same base. Plus x, 1 times 1 times 2 is going to be 2. X, multiplying x cubed and x to the power 1. You're going to add the exponents. They are the same base, so you're going to add the exponents. So 3 plus 1 is going to be 4. Now, I can add these together because they are the same base with the same exponents. So 3x plus 2x cubed to the power 4 going to be 5. X to the power 4. Check what we got. We got exactly the same side here. That means to find the product for x squared times x cubed, we have to use this rule because we get exactly the same side. 5x to the power 4, and on this side, 5 to the x power 4. So that means you can't do this one. This one is wrong. So that's the product rule. Every time when you see multiplication between two functions, you can, and they ask you to find the derivative, you can use this rule. Find f prime to the x, which is mean the derivative. So you will see f prime, which is mean the derivative, or you're going to see d over dx. So now we need to find the derivative f prime for f of x. So we have two functions, and the product, it's a dot between these two functions. This is f of x. This looks like this is the g of x, the second one. So that's mean f prime to the x is going to be the first function here, which is 3x minus 2x squared times the derivative for the second one. Now here's the important thing. The derivative for the second one. What's the derivative of 5? 0. Because it's constant. What's the derivative for 4x? It's going to be 4. So I'm going to write down here 4. So we've done it from the first one. Plus the second one, which is 5 plus 4x times the derivative for the first one. Let's check the derivative for the first one. The derivative for 3x is going to be 3 because x, 1 minus 1 is going to be 0. X to the power 0 is going to be 1. That means 3 times 1 is going to be 3. Minus the derivative for 2x to the power 2. 2 times 2 is going to be 4. That's mean minus 4 x 2 minus 1 going to be 1. Now we just have to simplify. This is the product rule. This is the first one times the derivative for the second one plus the second one times the derivative for the first one. Now what I have to do, I just have to simplify it. I can distribute 4 on the parentheses. So 4 times 3 is going to be 12x. 4 times negative 2 is going to be negative 8 x squared. Plus, I can distribute these two parentheses or these two binomial. So 5 times 3 is going to be 15. 5 times negative 4, negative 20x. 4x times 3 is 12x. And 4x times negative 4x, negative 16x squared. Now, next step, I have to combine the like terms. So here is 12. This one, and this one. I have to put 1 9. $12x plus 12x is 24. 24 minus 20 So here is 4x. -8. -16 going to be -24x squared. And the plus as the left plus 15. And we're just going to write down from the highest exponent to the lowest one. So this is the right solution. But I'm going to write down as a 24x squared plus 4x negative 24x squared plus 15. That's it for this example. If f of x equal 1 plus x squared and g of x is the second function is square root of x. So here's the thing. This is really important because we have radical here on this side. So the easiest way to work with radical is to convert it to a rational. If you remember, there's a rule that says to convert radical is going to be x n divided by n. Convert the radicals to rational exponents. So that's how we're going to work with this one. I need to use the product rule. So it's going to be f prime to the x. It's going to be the first one, which is 1 plus x squared, times the derivative for the second one. But before that, let's write down the function so we can use the product rule. F of x is going to be 1 plus x squared times, I'm going to write down this x, 1, and here's square root, that means 2, 1 over 2. Now we can use the product rule. F prime to the x is going to be 1 plus x squared times the derivative for the x to the power half. Here is the exponent. Here is x. 1 over 2 minus 1 is going to be negative 1 over 2. We done it from the first part. The plus. The second one, which is x to the power half, times the derivative for the first one. The derivative of 1 is 0. The derivative of x squared is going to be 2x. So here it's going to be 2x. Now we just have to simplify it. Here is f prime to the x going to be equal 1 plus x squared. This one, x to the negative 1 over 2. I can write down as a 1 over the positive exponents. So this side is going to be 1 over 2 and here is x to the positive exponent plus on this side here is 2x. X 1 over 2 is the same thing, square root of x. We'll keep going and simplify it more. Now on this side, can we simplify it more? Can I write down f prime of x equal this one times 1 going to be 1 over x squared over 2 square root of x. And here on this side is going to be 2x square root of x. That's it. We can't simplify it anymore. You want to combine these together? Well, our goal is just to find the derivative. There is a rule, it's also exponents rule. It says here, I'm going to write down the rule here. If you have a number with negative exponents, okay? Any number with negative exponents, I can write down this 1 over the number with positive exponents. Okay? So let's go back here. Don't confuse yourself about 1 over 2. 1 over 2, is that the same thing? Yes or no?
Yes.
Because 1 times x is going to be x to the negative 1 over 2. And 2, this is over 1. 2 times 1 is going to be 2. Yes or no? Now, next step, don't look to the 2. I'm looking for this one. A number with negative exponents. Can I write down this as 1 over the number with positive exponents? You see, only on the top part, I'm using this rule. Number with negative exponents is going to be 1 over the number with positive exponents. And here is the 2. Now I have division between 2 fractions because this one is over 1. So the next step, I'm going to write down the top part here, which is 1 over x to the negative half, to positive half, times the reciprocal for this one. 2 divided by 1 is going to be 1 over 2. Now, if you multiply these 2 fractions, it's going to be 1 over 2x to the half, which is the same thing that we got here. 2, 1 over x to the 1 over 2. You got it? The derivative for y equal x e to the power x. Now, this is exponential function. How are we going to find the derivative? The same thing. It's the product rule because x it's a function and e to the x it's a function. Now, it's y. That's why the derivative for the y is going to be dy over dx. Okay, that means here is the derivative, d over dx for the y function, which is a product between 2 functions. So it's going to be the first one, which is x, times the derivative for the second one, the derivative for the exponential function. If you remember that, e to the nx is going to be n e to the nx. Do you remember that? That's mean you're just gonna write down the exponents here with the x in the front, the function. So the derivative for e to the x, that's mean d over dx to the e to the x. I'm just write down the rule. Plus the second one, which is e to the x, times the derivative d over dx to the x. Now, this is the rule. Now, this is equal. Here is x. The derivative of d over dx to the ex. The number here is 1, so it's going to be 1, and the same function e to the x. Plus, here is the second function e to the x. The derivative of x is going to be 1, so times 1. That means it's going to be x e to the x plus e to the x. I can take e to the x as a common. If I took e to the x as a common, the left from this side is x. Plus, if I took e to the x as a common, the left is. That's mean dy over dx is going to be e to the x plus 1. Both these are both is going to be right. So if you look to this example, y equal 2x cosine x. These are two functions, product between two functions. Minus 2 sine x, and here's again another function. So we have to use the product rule here, minus, keep the constant, the derivative for sine x. If you want to use the product rule here, it's going to be the same result. Okay, you can use the product here, 2 sine x. I'm going to say, here is my first function, and here is the second one. Let's try it. So dy over dx. dy over dx is going to be equal. I'm working on this one, the first one. The first function, which is 2x times the derivative for the second one, which is cosine x, plus the second one, which is cosine x times the derivative for the first one, which is 2x. Doing that so you can see here's the rule, using exactly the same rule. Now here is the minus. Open bracket. We can use the same rule here because these two functions. So there's two ways to solve this one. You can write down the 2 and find the derivative for the sine, or you can use the product rule. Both is going to be right. But the main thing, by solving examples, you're not going to use the product rule here. You're just going to keep the 2 and find the derivative for the cosine. Okay? It's going to be easier. But it's the same thing using the product rule. Let's check that because it's two functions. So I'm going to say here is the first one times the derivative for the second one, which is sine x, plus the second one, which is sine x times the derivative for the 2. Let's check that. Okay. 2x. What's the derivative for the cosine x?
Negative sine x.
Negative sine x. So the derivative for the cosine is going to be negative sine x plus cosine x. The derivative for 2x is 2. There is the minus. 2. The derivative for the sine. What's the derivative for the sine?
Cosine x.
Cosine x. Plus. Here is sine x. The derivative for the 2 is 0. Because it's constant. That's why you see this side is going to be 0. So to find the derivative for the negative 2 sine x, you're just going to say 2. What's the derivative for the sine? It's cosine. So you don't have to do these steps. You're just going to say, okay, 2 on cosine x. Let's keep going now. 2x times negative sine x is going to be negative 2x sine x. And here is going to be careful, it's 2 and this is an angle for the cosine. So it's plus 2 cosine x minus 2 cosine x. Now combine the like terms, you have this one similar to this one. So it's going to be negative 2x sine x. Sit or the sit simple. Paper like these type of examples. They ask you if g of x equal x squared plus 1 times f of x. They're not going to tell you times, they're just going to tell you x squared plus 1, and here's f of x. And f to the number 2 equal 3. And f prime to 2 equal negative 1. They ask you to find g prime to the 2. That's mean find the derivative for the x first, then plug in g prime, find g prime to the 2. The first thing, I have only the function g of the x. G of the x equal x squared plus 1. And here is f of x. It's multiplication or product between two functions. Here is the first function, and the second function is unknown function. So now, to find the derivative to the x, it's going to be the first function, which is x squared plus 1 times the derivative for the second one, plus the second one, which is f of x, times the derivative for the first one, which is 2x. I'm using the product rule between two functions. Now, to find g prime to the 2, that means instead of each x, we have to plug in 2. It's going to be 2 squared plus 1 times f prime to the number 2 plus f to the number 2 times 2 times 2. G prime to the 2 equal. It's going to be 4 plus 1, so it's going to be 5 times f prime to the 2. F prime to the 2 is already here. F prime to the 2 equal -1. That means this one equal times -1. Plus f to the 2. F to the 2 equal 3. So it's going to be 3 times 2 times 2 is 4. That means g prime to the 2 is going to be equal -5 plus 12. G prime to the 2 is going to be equal 7. Be careful. This type of examples. I started from the easiest part, which is here is my function, is dot product between two functions, and I have f to the 2, f prime to the 2. So okay, I'm gonna say I need to find g prime to the 2. I'm just gonna look here. The first thing is start with g prime to the x. Okay, keep going. Okay. Any questions so far for this example? The next tool is the quotient rule. We're not going to do examples on this side.
They have a question. How is f prime to equal -1?
Because they're telling you this.
Oh, they're telling you, okay.
Yeah, everything here, they're telling you, find.
Wasn't that
So here is the given information, and they ask you to find f g prime to the 2, okay? The quotient rule, when you see a rational or between two functions, like this function divide by another function. For example, f of x divided by g of x. So now, to find the derivative is going to be always g of x, always start from this one. G of x times the derivative for f of x minus f of x times the derivative of g of x divided by g of x. So this is also important rule. I have a question I need you to work on and send it to me on Canvas. You need extra points. Before that, let's do some examples. I'm gonna write down the questions. Now we're gonna work with the quotient rule. So find dy over dx for y equal 5x minus 2 over x squared plus 1. To find this one, this is quotient, so I'm gonna use the quotient rule. So that's mean dy over dx is going to be equal. This is g of x, so it's going to be x squared plus 1 times the derivative of 5x minus 2. The derivative of 5x minus 2, if you want to write down the rule, yeah, let's write down the rule. D over dx to the 5x minus 2 minus f of x, which is 5x minus 2 times the derivative d over dx to the g of x, which is x squared plus 1. And everything is divided by g of x squared, that's mean x squared plus 1 squared. Now, next step is going to be dy over dx. It's going to be equal. Here is f of x, which is x squared plus 1 times the derivative of 5x minus 2. The derivative of 5x is going to be 5. The derivative of -2 is going to be 0. So the only thing is going to be just 5. Minus 5x minus 2. The derivative of x squared plus 1. The derivative of x squared is 2x. The derivative of 1 is 0. Over, there is going to be x squared plus 1 squared. Now, can we simplify it? Let's try. Distribute the 5 and distribute the 2x. So gy over dx is going to be equal. 5 times x squared is going to be 5x squared plus 5 minus, be careful here, 2x times 5x is going to be 10. 2x times 5x is going to be 10x squared, and there is minus here, so it's going to be minus 10x squared. Now 2x times -2 is going to be -4x. A negative sign, so it's going to be plus 4x. Everything divided by x squared plus 1 squared. Combine the like terms. It will be dy over dx equal 5x squared minus 10. It's going to be -5x squared. 5 by itself and 4x by itself. So plus 4x plus 5. And everything divided by x squared plus 1 squared. Check. Can you simplify it? Don't think so. We can simplify it. That's it. So this is the derivative for 5x minus 2 divided by x squared plus 1. Find dy over dx for y equal x cubed minus 3x squared minus 5 over 2x plus 5. We're going to use the quotient rule. So it's going to be the same thing, the derivative dy over dx equal g of x, which is 2x plus 5 times the derivative for f of x, which is d over dx to the x cubed minus 3x squared minus 5 plus, minus f of x, which is x cubed minus 3x squared minus 5 times the derivative of g of x, which is d over dx to the 2x plus 5. I'm telling you again. We're not gonna do these steps. If you don't do these steps, it's fine. You're just gonna go ahead and say f of x times the derivative for this one, write down the derivative. F of x times the derivative for this one, just write down the derivative. And don't forget, everything is divided by 2x plus 5 squared. That's mean dy over dx is going to be equal. Here is 2x plus 5 times the derivative of f of x. We're going to find the derivative for each term here. The derivative for x cubed is a 3x. 3 minus 1 is going to be 2. Minus the derivative for 3x squared. 3 times 2 is going to be 6. Here is the x. 2 minus 1 is going to be 1. The derivative for the constant 0, that's mean that's it. Minus, here is x cubed, minus a 3x squared, minus 5. The derivative for 2x is going to be just 2. The derivative for the constant is going to be 0. And everything is divided by 2x plus 5 squared. Next step, we just have to FOIL the first part and distribute the 2. Don't make mistakes here. There's a negative sign here. You have to distribute the negative sign. That's mean dy over dx is going to be equal. Now let's FOIL these two parentheses. 2x times 3x squared. So 2 times 3 is going to be 6. X squared is going to be x cubed, because we're going to add the exponents. 2x times negative 6 is going to be negative 12. X and x is going to be x squared. 5 times 3x squared is going to be plus 15x squared. And 5 times negative 6 is negative 30x. So we're done from the first part. Now here's negative 2. If you want to distribute negative 2, or you want to distribute the 2, then distribute the negative sign. So I'm going to say negative 2 times x cubed is going to be negative 2x cubed. Negative 2 times negative 3 is going to be positive 6x squared. Negative 2 times negative 5 is going to be plus 10. Everything is divided by 2x plus 5 squared. So here, be careful. If you want to just distribute the negative sign first, then when you're done, you're going to distribute the 2 on the new terms, okay? So now, dy over dx is going to be equal. Combine the last terms on the top, have x cubed, and have x cubed. So 6 minus 2 is going to be 4x cubed. Negative 12x squared plus 15 is going to be 3x squared. 3x squared plus 6 is going to be 9x squared. What's the left? Negative 30x by itself and 10. That's 10. Everything is divided by 2x plus 5 squared. That's it. We can't simplify it anymore. So this is the derivative for our function. Part of the trig functions, we already know the sine, the cosine, the derivative for these, the exponential function. Now we're going to add the derivative for the tangent is going to be secant squared x. The derivative for cotangent x is going to be negative cosecant squared x. So be careful here. The derivative for the secant is going to be secant x tangent x. The derivative for cosecant x is going to be negative cosecant x cotangent x. There are some rules, always we're going to use it. You see the notes? It says cotangent x is going to be cosine x over sine x. Cosecant x is going to be 1 over sine x.
Are we supposed to know every single rule, or when we're doing the exam, we're going to have like a sheet? We don't.
You can use the sheet, it's fine. But I prefer you memorize that. Because when you solve example, you don't have to look to the sheet. You can say, okay, I'm going to use this rule. But it's fine, you can use the sheet of notes. But I prefer, if you want to be perfect on these, memorize it. Okay? And cotangent, I'm gonna post another notes for all the trig functions. Cotangent x is going to be cosine over sine. Cosecant x is going to be 1 over sine. And this is, I call it the golden rule. I have two rules. Here's the first one, which is always when sine squared x plus cosine squared x equal 1. This is really useful rule, which is came from the Pythagorean theorem. We don't have to prove it. So if you look to the next example, y equal x minus tangent x. To find the derivative, I'm going to say dy over dx is going to be, the derivative for x is going to be 1 minus. The derivative for the tangent is going to be secant. So you're just going to say secant squared x. That's it. That's the only thing they ask you. Find the derivative. For the next example, we have two functions. We have x and we have secant x. Be careful. This x, it's a number by itself. This is an angle for the secant. So to find the derivative, we have to use the product rule. We're going to say dy over dx is going to be equal. The first function, which is x, times the derivative for the second one, d over dx, the secant x, plus the second one, which is secant x, times the derivative of the x. You can put brackets, you can put parentheses. You see, we use the product rule. So the derivative for the secant x is going to be secant x tangent x. That's mean x times secant x tangent x plus here's secant. The derivative for the x is going to be times 1. So on this side, you don't have to write down parentheses because it's multiplication. So give you x secant x tangent x. And here is going to be times 1. X secant x tangent x plus secant x. Take the secant x out as a common between these two terms, because you see everything here is multiplication, and here's the term by itself. So here is secant x as a common. The left here is x tangent x plus 1. That's it. That's the whole thing for this example. The higher order derivative is also important. So here's the first derivative. That's how it looks like of d over dx. if they ask you to find the second derivative, there's the second derivative, that's mean double prime here. F double prime, that's mean this is the second derivative, or d squared over dx squared. So when you see this sign, this means the second derivative. When you see double prime, this is the second derivative. The third derivative, the same thing. The fourth, check, we're not gonna keep putting the primes. So they're gonna say y, and there's a small parentheses with the 4. That means this is the fourth derivative. The same thing here, f 4 with the small 2 parentheses. This is not exponents, because this is a function. The same thing here. Now d4, that means this is derivative, the fourth derivative, and keep going with the fifth, the sixth derivative, the seventh, and it's going to be the same thing. Now, if you look at this example, let's find the fifth derivative. So find y prime, y double prime, y triple, y to the fourth derivative, and y to the fifth, which is going to be exactly the same rule. So we're going to start with the first one. Y prime is going to be, let's find the derivative here. 5 times 4 is going to be 20. Here's the x. 4 minus 1 is going to be cubed. Minus 3 times 3 is going to be 9. Here's the x. 3 minus 1 is going to be 2. Plus 5 times 1 is going to be 5. 1 minus 1 is going to be 0. That means it's 1, so that's it. The derivative for the constant is going to be 0. This is the first derivative. Y double prime. I'm not going to go back here. I'm going to start from the first one. I'm going to find the derivative for this one. Going to be the double prime. So now 20 times 3, 3 times 0 is going to be 0, 6. Here's the x. 3 minus 1 is going to be 2. Minus 9 times 2 is going to be 18. And 2 minus 1 is going to be 1. Here's the x1. The derivative for the constant is going to be 0. Let's keep going. Y, the third derivative is going to be 60 times 2 is going to be 120. Here is the x. 2 minus 1 is going to be 1. Minus 18. 18 times 1 is going to be 18. And here's, put down the x. 1 minus 1 is going to be 0. So we don't have to write down this. This is the third one. Now the fourth one, 120x is going to be 120. This is 0. And the fifth one is going to be 0. But it's just constant. We're taking the derivative for the constant, it's going to be 0. That's it for this example. The last part of this section, they're telling you S open T is the position function. On certain time, the position function of a certain object is going to be defined by S of T. The velocity of T, how are you going to find it? By finding the derivative. The derivative of the position function, okay? The acceleration, which is going to be the first derivative of the velocity, and the second derivative of the position function. So here's a simple example. If they ask you, if S of T equal x to the power 4 plus 2x cubed minus 3x squared minus x, find the acceleration at t equal 2. So S of T is equal x4 plus 2x cubed minus 3x squared minus x. I'm going to find the derivative because the acceleration is the second derivative. So the first derivative, which is the same thing, the velocity, equal. Find the derivative here, which is 4x cubed plus 2 times 3 is 6x, 3 minus 1 is 2. Minus 3 times 2 is going to be 6x, 2 minus 1 is going to be 1, minus the derivative for x is going to be 1. So this is the first derivative. Now I need to find the second derivative. That means s double prime to the t, which is the acceleration, equal 4 times 3 is going to be 12x, 3 minus 1 is going to be 2. 6 times 2 is going to be 12. Then the x 2 minus 1 is going to be 2, and minus 6, because this one is going to be 1. Now, the acceleration is going to be, we're going to plug in t equal to a over t, which is equal s double prime over t. Let's plug in the 2. So plug in 2 here, so it'll give you 12 times 2 squared plus 12 times 2 minus 6. 12 times 4 is going to be, it's going to be 48. 48 plus 24 minus 6. Yes or no? So 72 minus 6 will be 66. That's it for this section. Yeah, that's good. Just you can try fix these, because this is supposed to be for the x. Okay, so just change these x. This of the t changes to x.